Hello everyone. So we are in the discussion of Matplotlib, where we have discussed many stuff like what a figure is, what's a plot, and what are the different functionalities that Matplotlib provides. Now today we'll start our discussion with types of plots. Okay, most of you people might know these plots, so I'll just gloss through them and I'll show you the syntax of the Matplotlib, how Matplotlib allows you to do such kind of stuff. And we'll start with what are called as pair plots, pairwise. We have something called as pairwise data. So what is this pairwise data? So if you see, this pairwise data involves two items at a time. So it might be two items, two objects, or maybe any two entities, and we want to somehow figure out a relation between them. Okay, and this type of data is useful when you have to do comparison. Okay, if you want to do comparison, let's suppose you have two quantities and you want to compare them, and if you want to rank something, so okay, if you want to rank, or if you let's suppose want to have the similarity, you want to find similarity, because now we have two entities, two quantities are two objects. So if you want to make a comparison between things, or if you want to have something, you want to have rank them, or you want to get the similarity of the object, so it is better. And that time this pairwise data is sort of useful. There are different types of analysis, which sometimes it's called as multivariate, bivariate, and we have univariate analysis also. So right now I'll tell you why this pairwise data is important. So let's suppose take an example of recommendation system. Okay, many other platforms like YouTube, you have seen Netflix, you have seen on Facebook, Instagram, and all of these do give recommendations. So there they have to rank these things. Okay, so let's suppose there are users, they have to find similarity between user 1 and user 2, user 3, something like that. And in a similar fashion, if you see movies, they have to find similarity in the movies. So in that they have to do this pairwise. They have this pairwise data, and they have to find either comparison or the rank or the similarity. Okay, similarly in, let's say you search something, similarly when you are search, and Google has to has a ranking algorithm, it has to rank. So all of these things, if you see, in a way it is a pairwise data. You have one thing and you have other thing, it makes a pair, and you compare it in certain ways. You compare it maybe to get the similarity, you compare it to see what is better, and something like that. All these things constitute the pairwise data. And now the first plot that Matplotlib gives us is called as line plot. Line plot that we have been seeing, I think, since day one. So whatever we did, we saw it in the line plot. So the first thing, I'll give an example. Let's suppose you want to see temperature change. Okay, now we have date and the temperature. You want to see how is this temperature changing throughout the time. So you can plot it by using this line plot. And the second thing is stock prices. Many of you might be investors in stock market, that you see those patterns where the stock price either goes up or goes down, and there is that pattern formed. And then you can say, if many of you might be having your own business, you want to track your sales over time, and sometimes you want to monitor your health. Many of these plots, they come with where is the help? So what will give this line plot? What is the main objective of that line plot? The first thing many people see is that line plot, they give us some trend, so it will help us in finding some trend. So what is trend? Either if the thing is going up or going down, and it will also tell you the correlation. Okay, not the causation though. What is the correlation? Like maybe one thing is correlated to other. If something is increasing, maybe other thing is decreasing or increasing, and depends on if they have a positive correlation or negative correlation. Okay, so these are the things that we'll do. The first, we'll see this, the first plot is line plot. So we have been seeing this line plot I think since day one. I'll just again create some dummy data and show you, just for the sake of completion. I'll go to the code window and show you that. I suppose the code is visible. I just created a notebook up front. Okay, so what the first thing is, we'll import these important libraries. Import pandas as pd. Let me run it first so that it gives suggestions. And then what I'll do is I'll import matplotlib dot pyplot. Okay, dot pyplot as plt, and then I'll also import numpy as np. These are the things I want. And then what I can do is I can create days. So you know how to create days by using pandas. So we have seen this also in pandas in the time series. If you want to create days, so what I can write is, so days is equal pd date range, and this is the start and how many periods, and this frequency means I wanted day wise. So if I just print these days, you can see what will get printed. So here we have, this is the index, date time index, and you got the date from 2023/7 first, and you got 31 days. Okay, this is the index. And now let's suppose I'll create a temperature which will be random, some random temperature I'll create by using numpy. Okay, so if you see this temperatures, so focus on this. So this is np.sign Okay, so it is giving me sign, and this is the x value of that. Okay, if you see this is the x value, so np dot sign of that value. So these are numbers from 0 to 3 pi, and then I'm saying give me the 31 interval. So I'm giving this to np comma sign, and then I'm adding some random numbers from normal distribution. Okay, and some 31 numbers which are from 0 to 1, and then I'm doing some multiplication of 5 and then 25. Some I'm just creating some data. If you see these temperatures, I'll just print the temperature over here. So you can see this. These are the temperatures for 31 days. So these are my days. These are my temperature. I just wanted to have the temperatures to follow certain distribution. That's why I just added this normal distribution and add these numbers together, multiply it with the 5 and add 25. Okay, and these are the temperatures I'll get. Now if I want to plot, okay, if I want to plot this, so the simple thing that I can do is I can just plot. I can initially create a figure. There are two ways to plot. One is called as object oriented approach, and second thing is called as pie plot approach, where you use the pie plot. So because pie plot is a syntax, I'll use that, but you people should know by now that you can do the same thing by using the object oriented approach, which is much neater and cleaner. So here what I have done is I have created a figure which is size 10 by 6, and then I'm saying plot these days and temperature, and you all know these arguments. This color is the orange color, marker is O, line style, line width, marker size we have shown, everything. So if I now just show it, you can see the plot. So it is becoming a little bigger, so I should decrease the size. Let's keep it 8 by 6. 8 by 6 is even bigger. It's still bigger, so we'll create it 6 by 4, something like this. Now we can see this plot fits. The problem is the dates, but we can adjust these dates after a while. So you can see now this plot is sort of line plot, and it tells you the trend. That suppose for this from this date to this date, you can see there is a spike, and slowly it increases, and then it suddenly decreases, and then it again increases. There is some sort of trend is followed by there. Okay, so if we now want to add these title labels, you know how to add title label. Just for the completion, I'll just paste the code over here. So plot title, and plot this x label, plot this y label, and then this you can see it over here. So daily temperature on trend over a month, and this is the date, and this is the temperature in degrees Celsius. And now what you can do is you can also add a grid and rotate this x-axis, because now the dates, it should look at least cleaner. So how to do that? So just add this title. Oops, I have just pasted the same code. Let me just copy this one. Okay, you can see now I have added grids, and I'll say x ticks, rotate them 45, so that this, as you see, these dates are looking messy right now. So I want to rotate them by 45 degree, and then show the layout tight. It will add some padding and stuff like that. Now you can see that these dates became a little bit better. Okay, because I tilted them 45 degree. That's what this x ticks did. Okay, now plot.show, when I did that, plot.show even, so I can just say this is plot.show. It should be added now, because irrespective if you add this or not in the IPython, it will still show, but when you are coding in some ID, you should add this plot.show so as to see the plot. Okay, so this is the plot that we saw. Okay, this is the first plot, that is our line plot, where we just have these lines. You can see, maybe you can also do the first thing I said is you can do the comparison, and you can do the comparison day wise. Okay, this day was sort of hotter, this day was colder, and also you can find outliers. Maybe let's suppose you are in the summer, okay, and one of the days is quite cold, then you call that day as an outlier. So how can you see the outliers? Let's suppose I'll just plot some plots. Okay, maybe I'll just plot a plot where I'll show you what an outlier looks like. So I'll just paste some code, because that's somewhat what we have done so far. So here if you see, oops, unterminated, something is unterminated. That's why even with this code, with the copy paste code, it is still showing errors. Okay, now you can see this. This is the trend that we saw, and then you can see I don't want to go into the moving average right now. So you can see outlier detection. Let's suppose these points are called out, these red points are outliers. Let's suppose this was a trend, one, this, and this. So there was a particular distribution that was follow the points, and this is random, but here by outliers I mean that the points which does not follow the usual distribution. Let's suppose some days in the summer, usually there is a range of temperature. If that range is not followed, some day could be way cooler, so we can call that point as outlier. And in the similar fashion, if you have, let's suppose, some images, and we have all the images of cats, and there is one image of dog, we can call that image of a dog as an outlier, because it is not among that, it's not from that distribution. Okay, and you can plot this scatter plot, you can plot this line plot, and see if you have outliers also. So you can do this by using this line plot. Okay, the second plot that we have is called as scatter plot. Okay, So I'll also parallelly show you the documentation where I'm seeing all of this. I'll show the documentation. Give me a second. So I hope now Chrome is visible. So this is the documentation. The first plot that we saw is this plot, plt.plot. So this was our line plot. Okay, and they have written quite a little, but I'm taking it from here. So this is the pairwise data. They are showing the pairwise data for the first thing. I hope that this is visible. Documentation, in the documentation, if you go to this plot types, there are a lot of plot types, but they are just showing some of them, and we'll cover most of these plots so as to show what is the work. So this is the first plot that we saw is this plot xy, and this is called as line plot. So you can see this is a plot y versus x as lines or markers. So why is this called line plot? Because if you don't give anything, so it will plot a line. If you just give it markers, then it will plot markers. So it will plot either these lines, okay, or it will plot some markers like this. The syntax is similar that we showed here. They are doing it in object oriented style. Okay, they are creating this figure and axis and then selecting this axis. Okay, so this is what will follow. So we are done with this plot. So I hope that, because we have been doing it since day one, this plot. Now let's move on to the scatter plot. Okay, so give me a second. Any questions on this plot? I think there should be no questions because we have been seeing it. And the questions would be where is it applicable? Yes, questions. Yes, go ahead.
सर जैसे कि हम जो आपने वेरिएबल लिया टाइम और जो टाइम वर्सेस डेट था, तो
Yes,
हम
yes.
इसको रिवर्स भी कर सकते हैं, फिर हमें वो चेंज मतलब वो इंटरप्रिटेशन सेम मिलेगी
Yes, yes,
अगर हम
yes.
चेंज करें एक्स
If
को
you are
वाई
saying,
पे.
you are saying if you change the axis, तो time हमने axis पे लिया था, you can take it on y axis. Yes, you can change it.
सो इज इट फाइन? क्योंकि मैंने कुछ पेपर्स में देखा था, उन्होंने मतलब जो यूजुअली हम उन्होंने क्या लिया था, उन्होंने नंबर ऑफ इटरेशंस यूजुअली वाई एक्सिस में लेने थे, तो वो किसी इनिशियल पॉइंट पे नंबर ऑफ इटरेशंस ले रहे, लेकिन उन्होंने जो नंबर ऑफ इटरेशंस ली थी वो फिर एक्स एक्सिस पे ली थी, तो जो इनिशियल पॉइंट था वो वाई एक्सिस था, जो कि यूजुअली हम नहीं करते, हम जो कॉमन वैल्यू होता है वो हम एक्स एक्सिस पे रखते हैं.
I'll tell you the reasons. I'll tell you rationale behind why people switch axes sometimes. So switching axes sometimes makes it easy to interpret from the graph. And let's suppose if you keep epochs on the x-axis and you keep the values of loss, usually if you plot loss function, so when you train a machine learning model or deep learning model, there is something called as loss. So you see with each of the epoch, which each the iteration is the loss going down. So it makes sense to put the number of epochs on x-axis and the loss on the y-axis. Sometimes what happens is if you are having a lot of things, so you can switch the order, but the main point should be you should make the graphs easily interpretable. Okay, and it might be a personal choice, or some people might like it that way, but the better way is because these graphs are there to make the data interpretable. So the first thing that you should keep in mind when you're plotting anything, so you plot it in a way so that it makes it easy for the reader to get sense out of the graph. So it doesn't matter how you plot the x and y axis, but the your point should be I should be able to make the reader much comfortable while he's interpreting or reading the graph. That is my take on it. Okay, let's move ahead then. So the second plot that we saw in the documentation is called as scatter plot. Okay, and there are a lot of things that I can talk about these plots. The whole documentation is filled with it, so I just wanted to show you what are the things that are there and why will it be used. And you will use these line plots. The first, as Muzaffar rightly brought it up, you will use these line plots or maybe these the direct plots, or why we have these markers in the loss functions. Okay, so good that we would discuss this. So there is something called as training loss and validation loss, and there is something called as testing loss also. Okay, so you'll usually see in the paper the plots will be like this. So they'll start with epochs. Let's suppose this was the first epoch, they'll go to, let's suppose, some 100 epochs, something like this. In the first epoch you'll usually see loss going like this and in between spiking, and then you'll see it plateauing out. Okay, something you'll see a figure like this. Okay, a loss, and this, let's suppose, it training loss, and you'll have to plot these things. Now we have tracking softwares, not I won't say software, tracking libraries, like we have something called as MLflow, we have something called as TensorBoard. Okay, and there are a lot more. There is something called as weights and biases, and all these platforms and now all these libraries, they give you this tracking mechanism where you see, okay, is training loss decreasing, what is the validation loss, because you have to tune the hyperparameters. and we'll see once we reach the training of these deep learning networks. We'll see all these things once, but you will have to have a sense of how these graphs are plotted. Okay, so because now at this moment of time, you will directly integrate these ML flow, tensor board, or maybe weights and biases into your code. But sometimes you might be having a situation where you are stuck. Right now I was stuck in that situation. I was training a model and I was getting the loss. I had to keep a track of that, but the problem was that I hadn't included this tensor board and ML flow code. So what happened is there was no way of stopping the training, because each epoch takes some 24 hours or something like that. So it was better to just pick up the loss and just plot it, and I was doing it manually. So if I understood these graphs, then it would have been easier for me. Okay, so that's at least one motivation you should see from a machine learning, deep learning perspective. You'll see these graphs everywhere. Okay, and this is one of the instances where I'm giving you'll have to see the losses, training loss, validation loss, and testing loss, and then you will see the statistical data also. There will be a lot of scores like F1 score, metrics, and that will be shown in graphs in the research papers, and you will have to make sense out of these graphs, and you'll have to say, okay, F1 score is decreasing and this is the F1 score. Then there is something area under curve, AOC, there is accuracy drop there. All of these graphs, more or less, you will see that these line plots are there. Okay, now the second is scatter plots. Okay, so what is the scatter plot? So scatter plot displays individual data points, okay, without connecting them through the line. So here if you see in the line plot, it was connecting them to the line. But if you don't want to connect it to the line, you just want the individual points. So okay, let me give you an example like this. So I have a data, let's suppose, and let's suppose as a scientist you are data, and you are maybe exploring does the work hours, like if you spend this much of hours studying, how is it impacting the performance of students? Okay, you can have student like this, you can have student, and then let's suppose you can have hours studied, how much has the student studied, and you can have exam score. You can have data like this. Maybe you collected this data somewhere and you want to see, is there some correlation? I won't say causation, is there some correlation? Okay, if the student has spent this many, let's suppose student we have 1 2 3 something like this is our data, and then hours studied somewhat 5 hours, 7 hours, 8 hours, 2 hours, 6 hours, something like this. The data is like that, and 70, 40, and these are the marks given. So let's suppose this is our data, and now what if we want to see, is there some correlation? Is there a positive correlation? Is there a negative correlation? And is there a student who is outlier? That means, let's suppose usually we assume that the more you study, the better mark you should get, and maybe there is a person who studies very less but still gets good marks. Okay, that may be considered as an outlier because it does not follow the usual trend. Okay, if you have such kind of data, so there the scatter plot makes more sense, because you have to see for individual points. Okay, let's go to the code window and show you that. This is the code. Okay, so the first thing that we'll do is we'll say hours studied. I'll just copy some data. This is hours studied. Let's suppose these are the studied hours for each of the students. Okay, and then we'll say exam scores corresponding to these hours. Okay, this is 5 hours, then he got 70, 7 hours he got 85. Now what I want to do is I want to plot a scatter plot. So the first thing is I'll do it again in the pie plot style. There are two styles, or object-oriented style or the pie plot style. So pie plot style code is more concise, so we can do it if you want to do it on the fly, but if you are actually doing it on the project, the better suggestion would be that you should go with the object-oriented style. So now I said plt.figure, I gave the figure size, so I'll keep it as 6x4 so that it looks a bit smaller. And after that, what I'll do is I'll say plt.scatter. plt.scatter, and if I just now see it, you can see the scatter plot. Okay, you can see there is this student which studied for 2 hours and it got 50 marks, and you can see a linear trend sort of thing. The more you study, the better marks you got. 10 hour person, he got above 90, but there is an outlier still. There was this person who studied for, let's suppose, 2.5 hours, but he still got 90 plus. Maybe he's an outlier. Okay, you can detect outliers by using this. If you have a lot of data and you have to do this sort of pairwise comparison. So here it is pairwise comparison. You have a student and the corresponding marks, and you can do the comparison of these things. And again, to put these title, label and stuff like that, I just will, but by now you should be experts in this. You should be experts in just filling these titles. PLT title, we have this title. PLT X label, we have the Y label, we have the grid, and we are showing plot.show. So this looks a bit neater. Okay, relationship between hours studied and exam scores. Okay, here you can also detect outliers. So outliers detected if it does not follow the normal trend. Okay, so the interpretation is the first thing, how we can interpret is that there is a positive correlation. What's the meaning of positive correlation? That the plot shows that as the number of hours are increasing, similar the score of the students, and there's a positive correlation, and there is a trend, there's a linear trend. The scatter plot shows that a linear relationship between hours and studies. Why is it linear? Because it follows a linear graph. If you see it, sometimes it may be quadratic, cubic, and howsoever it is, we have seen those in functions. So but it follows a linear trend, and outlier, we saw one of the student is an outlier. So what scatter plots are better for? So you can visualize relationship between two continuous variables. So here we have R studied and we have the exam score. Both of these are variables which take a continuous value, and then you can identify correlations. Is there a correlation? Okay, and you can identify trends, and is there a pattern also? Then you can also detect anomalies, or you can detect outliers. If there is an outlier, you can say, oh, this point is somewhat not following the trend, so it must be an outlier. So again, the applications are enormous. You will see it in a lot of these things. And one important thing that I'll show you, I wanted to show you, is this scatter plots are sometimes better used for what's called clustering. Similar points are clustered together, and you find, okay, these points, they're coming in one cluster, these points are coming in other cluster. So we have a lot of algorithms in machine learning. So they're called as clustering algorithms. So they come in the branch of learning which is called as unsupervised learning, where we cluster these things together, and you actually don't have labels corresponding to them, but you still can see that there are clusters of these things. So let me just show you one example of clustering. I'll just create some random data. So I'll say I'll have some group of people who have low income and low spending. So I'll have 4 groups of people: income low, spending low. This is one group of people. Okay, then I'll have income low, high spending people. So I'll have this group of people. So income low, high spending, and spending high, something like this. Okay, I'll make 4 groups of people. But these points will be, this is just a made up data, dummy data, but in the real world you will get some data, and then you will have, when you plot this data, and you will see a clear pattern in there. So what I can do is I can have a scatter plot of all these points. What are these points? I can plot them. Okay, if you see this, there are 4 clusters formed. Okay, let me just make it a little bit less. Let's go 6 by 4. You can see 4 clusters are being formed, and these people are low income, low spending. If you see, these are high income, low spending, and these are high income, high spending, and these are low income, low spending. You can see, if we, let's suppose, did not know it, we just had this data, when we plot it, clearly you can see, oh, there is a cluster. So there is some cluster, these people are getting together, there is an aggregate of points over here. Okay, they'll have certain property, and this and the cluster. Okay, and we have this cluster, and we have this cluster. So if you see, if you scatter these points, that's why they're called scatter plot. You can see these points are scattered around, and from this you can easily, if you have data, you can easily, by directly eyeballing it, you can see that there are 4 clusters formed. So here I knew that I on purpose made the data like this, but sometimes you'll get a real world data and you have to make sense out of it. So when you plot it, let's suppose 2 features the data. The features could be, let's suppose we'll do an EDA, there we'll have iris flower data set. There will have petal length and petal width. Once you plot them, you can see that on base of only 2 features, you can just cluster these things together. Okay, and here that you can clearly see that if you plot a scatter plot, it will give you a sense of which points look alike. Okay, because they lie quite similar. So as I said, it will help in correlation analysis, identifying outliers. It will do trend analysis. You can also do clustering, and then you can do comparative analysis also. Okay, so with this, you can, because a lot of these graphs in the research papers, what you will do is you will see this lot of experiment data by just showing these as like clusters. And maybe sometimes you will see ecological studies, biological studies, where they are showing, okay, how was the spread of COVID happened, and they'll show it by using these graphs. Okay, they have a lot of implications, but here I'll just show you how these graphs are plotted. Okay, I hope that this is also clear, and you can do a lot of these things. Okay, I'll just say one more thing. I have written one more example of BMI calculation, so you can see that you can have different versions of these graphs also. So if you see this is BMI, this is cholesterol, and this is age. I'm saying scatter, and then here if you see this S is basically the size. Okay, based on this, just take this A in age, take this number and multiply it with 10, and based on the age, make the this circles bigger. So if you see these circles over here, they were of the homogeneous size, that was similar size. But if you want if you want these circles to be bigger in size based on a variable, so here age is that variable. Based on the age, you want the circles to be bigger, and you are basically plotting BMI and cholesterol. Okay, how is the cholesterol and what's the BMI, and but you are making the size based on the age. So if the age is more, the size of that will be bigger. And then alpha, you know, is the transparency, how much opaque or transparent you want it to be, and the color will be purple. So here we have a plot between BMI versus cholesterol levels. And if I just print it, you can see, okay, this is BMI and this is cholesterol. So here if you see, this actually is multivariate analysis. Now you are having three variables. You have BMI, you have cholesterol, and age. Now age is captured by the size of this. So age is captured by the size of these small dots, these markers usually, which are called as. Now you can see that this is BMI and this is the cholesterol. And now as the things get bigger, and let's make somebody 100 years old, 100, and we'll see this should be the biggest. You can see this got the 100 years old. Okay, so that's how the trend was followed. Okay, now we are doing here multivariate analysis. As I said that we only had two variables, but we had a third variable which we cannot plot in the 2D graph. But what we can do is, if we sort of capture the information in the size of this, so we can see that based on the size, we can say that, okay, the size is corresponding to the age. Then we have a comparison between BMI and cholesterol levels. Okay, and then you can do a lot of things. You can even color code them. You can have heat maps, a lot of things that you can see in the research papers. Okay, you'll have all these things. Maybe once you read research papers in detail, once you do your own analysis, you'll come to know a lot of things about these scatter plots. But again, the basic thing is that all of these plots are being provided by other libraries like Plotty, or maybe we have a Seaborn, that's the wrapper around Matplotlib. So here the focus is that you should just know the syntax, because I'll be using the syntax everywhere. So my method of teaching mathematics will be purely from visualizations. Because we have done linear algebra 3 lectures, prerequisites, I stopped it there. Why? Because I had to show you how to visualize these things, and I'll use all of these pictures probably. I'll just plot a vector, I'll just transform a vector somewhere. Okay, and that way you learn the mathematics way better. It's not just you are solving the things mechanically. You are giving in a question and then you solve it mechanically, but you know what am I solving? Okay, and what is happening underneath, and what is the physical thing that you are solving. And that's why we are learning these libraries. These libraries are just tools. Any questions till here? Any questions? Okay, one more application that you will quite see by using the scatter plots is once you have actual data and you have the models predicting something. So you have the actual, and you see you plot these things. So how you basically do that? So you do it like this. So you have the actual data. Let's suppose this is actual data, and let's suppose these are the predicted values. Okay, so when I predict them, you can see this is the scatter plot. So we have these dots, these are actual plots, these dots are the actual green. And then you made a prediction. Let's suppose this is a problem of what's called a linear regression. You will just fit a line to this data. It's called curve fitting. So when you fit this line, you can still see that there is some error. So this is the error. This dot point, this green dot is a bit away from the line that we predicted. Okay, and maybe this dot is also, and there is this dot perfectly fits the line, and this dot, but there is, you want to minimize the error. But you can here see that visually how far is your line. Okay, and this is one of the things that we'll probably use in linear regression. We'll try to fit a curve or a line through the points. We'll have points scattered around, and then I'll just come up with a line mathematically, and then we'll plot a line on the graph, and we'll see how good or how bad is that line. This is called as curve fitting. Linear regression, that algorithm is a curve fitting algorithm. Okay, because it tries to just fit a line, and then we have whole domain of curve fitting itself. I hope that you also got some clarity on the scatter plot. So I told you what it is used for, and I showed you some instances, some examples of the scatter plot, and there is a lot written in documentation. You can just hold in documentation and maybe test it and some tinker with it and maybe play with it, and you will get to learn a lot of things. Okay, pausing here for a second to take questions if you have any. Now we'll come to one of the again we are in the pairwise data. We are seeing the pairwise analysis. So there we first saw the line plot, and the second thing we saw is the scatter plot. Again, to reiterate, my point here is not to just show the syntax and show how it is plotted, rather than to give you a sense that if you have these scatter plots, what are they important for? If you have these line plots, what are they important for? And you will encounter them in your research papers, in your day-to-day tasks, like even if you watch news, if you watch stock market, you will see this. And in order to make sense of these, that's a much more important thing for me, because otherwise this syntax will be this will get changed from one library to another library, and you should know that all the libraries like Plotty, I said, Seaborn is there, Matplotlib, which we are studying, they do provide these methods where you can plot all of these things. Now coming to the next plot, which is called as bar plot. Okay, many of you will know this bar plot because cricket match they usually show these bar plots. So we'll have this bar plot. Okay, or this is called as bar chart sometimes also. So a bar plot, also known as bar chart, so it's a graphical representation of categorical data. Okay, we have a term here called as categorical data. So we have seen what categorical data is. If there is a feature which takes categorical values, by categories I mean, let's suppose gender. Gender is a categorical variable. Okay, it takes male and female values. Okay, and strictly takes male and female values, and this is categorical. Similarly, let's suppose if you take an example of let's suppose country. If we are talking about people, so people have let's suppose we have some 200 countries, under 200 countries, so it is a categorical variable. Each of the person in the world will have one of the values in the country, in the country column will have one of the values, so this will be categorical data. So what this bar chart is good for, so if you have this categorical data and you have a frequency representing that data, something like the frequency or value of each category, so you have categories and corresponding to the categories you have maybe frequencies or maybe some value or something, length, height, whatever you have. Let's suppose you have the people are living in certain countries, so in each country you will have the values for this. So you want to see, okay, again is this category, how much is the value or how much is the frequency, and you want to plot that. Okay, and in them it will be something like this. So you will have a chart and then there will be bars. It's called bar chart because of this. So there will be bars for each category. You will have these bars. You might have seen also in the cricket match where they show number of overs on x-axis, because the number of overs takes 60 value, 60 from from 1 to 60. It's a categorical value. Overs will take one of the values from 1 to 60, and then they'll show runs on this side. So runs will be on this side, overs will be on this side. Okay, so for each of them they'll have these bars. Okay, how many runs were consumed in each over. So because now these overs are categorical data, these are categorical data. Similarly, let's suppose height is so height, and let's say people we are plotting something versus let's suppose height and male female, something like that, average height. So we'll have two bars, one for the male and one for the females, and then we'll have average height of them. So this male and female, this is a categorical variable and it takes a certain value that we can show on the bar chart. So what is the advantage of bar plot? Again, you can do comparison, you can have a clarity, and it is better data representation for categorical data. So one case study that you will probably see, because many of you will develop websites or maybe work with e-commerce things, so there you will have to make a lot of these bar charts for sales data. So a retail store, let's suppose, uses bar charts to compare the sales across different categories. If you have electronics, you might have clothing, you might have some other goods, and they see, okay, how much revenue was generated by each of these categories. Okay, and similarly, if you work with, let's suppose you are a social scientist and you work with population distributions. Okay, government agencies offer plot these to show a population of different age. Let's suppose you have a religion. People have different religion and they want to see what is the population of each religion, and let's suppose what is the literacy rate of each religion, and they show it by using the bar chart, and usually for the survey results. And again the same thing for academics, when you are doing this comparison, you can again use these things. And if many of you will have your own startups, there you will have to analyze website traffic. How much is the website traffic? So what you can do is you can have different, let's suppose you have social media, let's say you want to analyze traffic by from which link do they were redirected from to my website. Was it a social site, was it a direct, was it searched by search engine or something like that. You will plot it, and accordingly you can take this informed decisions. Should I invest more revenue in which ad? Should I give Google more money to give more ads? Because you can see that from Google a lot of my visitors are there from. So you can just give Google. If you see that there are a lot of people coming from WhatsApp, so you can just maybe do much more WhatsApp marketing or something like that. And all of these things you will do by using these plots, bar plots. Okay, let's maybe write a code for this to show you some of these plots, and then maybe some changes also. So we'll do some comparisons also. So the first thing is, let's suppose we'll have the retail store, and in the retail store we have electronics, clothing, home goods, sports, and toys. We have these categories of the data, and then in each of these categories we have sales. Okay, let me just add these categories. So categories are list. If you see, okay, if you see, I have electronics, I have clothing, I have home goods, I have sports, and I have toys. These are my categories. Okay, let's suppose I run a store, and these are the things which I have in the store, and now I have to show the sales. Okay, and for, let's suppose for a month, these were my sales. In electronics, these were my sales. In clothing, I had 12,000. In home goods, I had 18,000, something like this. Okay, let's suppose you want to analyze which things are giving you good sales, so it is better to bring more stock of that. And then what you can do is you can just create a bar chart by just using plt.bar. This is a function. PLT dot bar, and then you have categories and these sales. Categories basically will go on the x-axis and sales will go on the y-axis, and then you are saying color and you know the markers. Okay, if you want to go to documentation, what you can do is you want to see the documentation of bars. I'll show you that. Just go to the documentation and here is the reference. Okay, and we are in the pie plot. Let's suppose if there is bar, so you can see this is axis bar. Go to the plot, I think PLT, if it is PLT 1 2. So matplotlib.py plot, so we have to go to pie plot. So this is our pie plot. So in this pie plot we should have this bar somewhere. Well, can you see it? If you can have bar, a lot of things to navigate. Now you can see this, here it is. So matplotlib.pyplot.bar, it takes x, it takes height, x and y, basically x coordinate and y, it takes width, how much width is the for the bar. So here the default is 0.8, and then bottom is none, and there are a lot of things you can just check these parameters and read about these parameters, what color you want, what edge color you want, and maybe we'll test them also. Okay, just bring up the code window back. Let's suppose I want to plot this first. So once I plot them, so you can see these are the things. So here I show the color. Now I want edge color, so I'll just add edge color. Edge color, the spelling should be right. Let's suppose I want it black or maybe red. Now you can see that edge color is red around these edge. This is that. The width by default is 0.8. You can change the width. Then you can say width. This is equal to 0.5. Make it a little bit thinner. You can see they got thinner. Now you saw that we have electronics, we have clothing, we have home goods, sports and toys, and here is the revenue. And you can put the X labels, Y labels and everything there. And let's suppose these electronics, if they were jumbled up, we can just rotate them also. So we'll put title, then we'll put X label, Y label, and we'll rotate these ticks, and then we'll also show a grid. So if I just do this, oops. So what I'm doing is I'm adding titles and labels. Title is this, and X label is product category, Y label is total sales in dollars, let's suppose, and X ticks is rotation, and then we have grid. This is add grid lines for your Y axis. Okay, this is just for that. If you just want for the whole grid, it doesn't make sense here to have the whole grid. So then we should delete this. So if you delete this, you can see that we'll get the grid. But it doesn't make sense because we just want the Y grid. That's why I have kept this axis is equal to Y and then plot.show. Okay, this is the center, and you can do a lot of things. Again, going back to the documentation to show you. Okay, this is the documentation where you see all the parameters that this plot can take, and then you have the important is this, and we had a discussion in the previous session, this star keyword arguments, and keyword arguments, it can take a lot of values over here that you can see. If you go down, you can see these are the values that can be taken in the keyword arguments, and each of these things are written. Okay, so these are the optional arguments, or maybe these arguments are there, which are many of them, I think all of them are optional except one probably. So this X is required. Okay, and height, it will take something else, and you'll have to see what are the optional arguments and what are the other necessary. Okay, so you will read it from the documentation. I just wanted to show you one plot. Now you can do the same thing for other plots also. If you have population by age, let's suppose you have the data of the population and you want to see how to plot that, how to basically compare how much age groups we have, and then maybe find the percentage. Okay, let's see that, because all of these examples are readily available. So what you can do is, so if we have this data, so the data is we have age groups 0 to 18, 19 to 35, 35 to 30, these are the populations, let's suppose, for your city, and then you want to plot them. Simple plot dot bar, and then age groups and the population, the color is green, and you can change the other things also. So the plot looks like this. Okay, and same for the website also. If you want to see the website traffic and things like that, and if you want to see customer satisfaction, you want to plot, you want to see the reviews for your product, and all of these things can be done. But one more important thing is, as rightly pointed by Muzaffar also, sometimes it becomes too clumsy if you write a lot of things on this. Okay, let's say if you write a lot of things, so let me just import one more data, that's traffic sample data, and I'll show you what can go wrong and why do we need some other plot. Okay, so what will happen is, let's suppose if I don't have this axis rotation, You can see that this direct organic search. So I am basically showing you traffic analysis. What is the source of my traffic? If I am having a website, and where are the people coming from my website? So some is direct, they're just searching my website. This is organic search from not sponsored search, like it is coming to, on the Google. And social media is, I have maybe have a handle on social media and referrals and email. There are different types of marketing. And now I have the visitor count. So now if you see this becomes too clumsy. You can see it like it is too congested. So the better point would be if I flip this graph. So if I make it horizontal, it should look much better. So what I can do is I can just add plt.bar h. If I do this, you can see this now, it looks way better. I just swap the axis. But here Matplotlib gives me the method bar h. So what it had done is traffic source is now on the x-axis, and number of visitors is on the x-axis, and traffic source is on the y-axis. So I'll have to also switch these. This is my y label now, and this is my x label now. Okay, now you can see this. Okay, now it looks beautiful, like email this and referral like this, social media, organic search direct. And you might have seen charts like this a lot, where they are comparing certain things. Okay, so the better point is, because my website is probably doing good, so organic search are more. Okay, direct search are smaller than that, and social media. And you can even sort this. Okay, you can sort these things. Traffic sources, maybe visitor count, you can apply a sorted method. Okay, and then you can apply sorted on these things. So you can do a lot of things just to sort these things. Okay, and then maybe also add the percentage. You can also add percentage over here to make the data more readable. And now what you can do is, one more thing that you can do is, you can have stacked bar chart. Okay, by stacked I mean, let's suppose you have certain values. You have value 1. I'll just create a data and I'll show you that, and then we'll read the graph. So let's suppose we have labels A, B, C, D, and we have two values correspond to that. And this is our data, something like this. Oops. Yes. So now if I show you the data, so this is my data. So I have labels A, B, C, D, and I have values 1 and values 2 correspond to the data. Okay, let's suppose you have two stores now. Okay, you have two stores. One store is in the east and one store is in the west. And you have these category of product A, B, C, D. And now you want to basically plot them and see the comparison. So what you can do is, now I'll use object-oriented approach on purpose, so that we'll cover both approach, pie plot approach as well as object-oriented approach. So how to do that? So we'll say figure comma axis is equal plt.subplot. So if you see this, figure and axis plt.subplots. Okay, and then after that I'll plot the first bar plot, and this is my first value. Okay, I'm doing axis dot bar. I'm selecting this ax, and I'm saying this is the label and this is the value 1, and give the color and give the label a value 1. And similar thing I'll do it for ax, same thing for the value 2. Ax dot bar labels value 2, and then I'm saying bottom, at the bottom keep values 1, and above you should have a value 2, and then I'll add these titles and stuff like that. So if you see, I say axis, set title is this, set x label, set y label. There is a difference, but so if you see in this pie plot, so we just say plt title, plt y label, plt x label. Here you will have to write different methods, set x label, set y label, but they have the similar functionality. But you should know that there is a small difference when you do it in object oriented approach. And then at the end I'll show plot.show. So if I now print this, you can see I have these, let's suppose these are my two stores. Okay, and this is value 1 and value 2, and for A category, B category, C and D categories, and you can see that value 2 is here. It's stacked basically on top of it. So that's why I said at the bottom, when I explain this bottom basically is value 1. Keep the value 1 at the bottom. That's why you see red of these bars at the bottom, and at the top you keep these values. So these are the values which we had. Value 1 is 10, and then we had 8. And if you want to see, let's suppose cumulative distribution, you want to see 8, 10 plus 8 is now 18. Now you can see that in both the stores, let's say store 1 and store 2, the category A product had this sales 18, and you can clearly see, let's not have this value 1 and value 2, let's put them as store 1 and store 2, so as to make more sense of the data. Okay, and this is the category A, B, C, D are the category. So I have two stores. Now you can see that product A, maybe let's say electronics, the sale of in A was 10, and sale in store 2 of A product was from 10 to 8, that is 8. Okay, that 10 to 18, that's 8. In total we had, the total sale was 18. And again for the B, what we had is for the B category, in the store A, in the store 1, the sale was around 15, and from 15 to let's suppose 24 or something, and these we can just adjust these marks also, and these markings on the y-axis. So I showed you the stack, how you can even multiple stack, you can add more stack if you have more stores. So it will help you in aggregate analysis. So here you can aggregating data also. Okay, this is called as stacked bar chart. So this is a stacked bar chart. Then let's suppose sometimes you want to have a group comparison. Okay, right now you are stacking the things, but what I want is I want to create groups. I want to have, I have store 1 and store 2 back to back, sort of these things. So what I will do is, so now instead of this plotting this bar, because they are it is plotting it one after the other. So what I can do is I can say plot this labels. These are my labels, and then plot the values 1, plot the values 2, right? And then what I should do is I should basically, if I just remove this, let's suppose, and I also put color. So I'll first show you what will happen if I do this. So color is equal to, let's suppose, green. If I plot this, so now you will see it happening on one on top of each other. Okay, now I have, if I just remove this, if I remove one part, if I remove this, so you will see this is the graph for store 1. So if I just remove the graph for store 1, so this is my store 2. Now basically what I want to do the comparison. I want to have these things back to back. I want to have for the store 1 and store 2. Okay, so how I actually want it, so better than showing it by the hands, I should show it on the tab. So I want something like this. So I want for store 1, let's suppose this is the bar, and for store 2, let's suppose this is the bar, something like this. This is the bar, store 2 and store 1. I want side-wise comparison, and this is for category A. Similarly for category B, this is, let's suppose, store 1, and this is store 2, something like this. Okay, I want to have a side-wise comparison. Now what I did is when I used this bar twice, okay, what happened basically is when I used this bar twice, the problem that happened is you got overlaying. One was overlaid on top of each other. So how to fix this now? Okay, how to fix this? Okay, this is a simple, very simple problem. Now the first thing what we'll do is, because we were using these labels, so what we can do is we can just do one thing. We can create x, we can create these values of x on purpose. So on these, because these labels were ABC, now I'll create some x values. So what I'll do is, so if you see over here, I did x is equal NP range of length. I created these many number of x's. So it will be from 0 to 4, it will be from 0 to 3, because 0, 1, 2 and 3. I created a numpy array which contains 0, 1, 2, 3. Okay, now what I'll do is I'll use this, instead of labels, I'll use this x. Okay, this won't solve the problem now. It will still be the same, just I converted this from 0.5, but now what I'll do is I'll shift these things. Once I'm plotting it for the first graph, what I'll do is I'll say I'll also have a bar width. So I'll just create a width, bar width. Okay, let's say bar width by default is 0.8, will keep 0.5 for each of the bar. So what I'll do is now I'll just shift the first bar. I'll say plot it from, let's suppose, minus bar width. Okay, and then I'll say do plus bar width. Okay, let's see what will happen. Okay, is it plotting? Okay, let's now say divided by 2 will also, I'm just shifting them. Okay, now you saw I just got them separated. Okay, I just got them separated a bit. Now what I should do is I should say bar width is equal to bar width to get them right. So this is bar width is equal to bar width, and similar for here also, because by default bar width is 0.8, so I have kept it 0.5, so I should say 0.5, so that I'm just removing the overlay. Okay, I hope, oops, there is some issue. Did I miss something? Bar width, there is no argument like bar width, so there is an argument width then properly. So we'll have to see what is the argument. So is it width? Yes, it's width. Now I can put it like this. So width is the argument. Okay, so this, now you can see this, you got a comparison. Okay, you can see this, you got a comparison. Let's suppose this is, now the problem here is I don't have A, B and C like that. So what I'll do is I'll say ticks by default. I'll say ticks will be my x. Oops, I'll say by default put me these ticks should be given these values. So I'll say, that's why it says the point is it should get labels. So I'll say x ticks. So here is this. Now you saw 0, 1, 2, 3. Now I can change this to ABCD. Let's suppose we have these labels. So I'll put labels over here. Again, I am getting some issue, but you got the point. The point is that I should be able to. Okay, so you have these categories. Now I did this X. Now it should work. So here the label, this is my store 1, keep it store 1 and keep it store 2. Okay, these are group bar charts and these are my labels. These are the values and these are the ticks, and my X tick labels basically are this. X ticks are X and labels that I'm putting is labels. So this is the legend. So now if you see this, this looks way better. Okay, and I have separated them also. So you can now see comparison. I have store 1, this is the blue store, and I have store 2. So I have labels. So instead of values, what I can do is I can just say sales, something like this. Now you saw that the difficult part was not the difficult part, but rather the tricky part is when we plotted this bar and bar, they got overlapped with each other. So what we did is we defined this bar width. We said, let's suppose bar width is 0.35 in this case. So the initial, when you plot it, just plot it left of this. So plot it and shift this X by this value, okay, and divide by 2. And again the right bar, plot on the right side and shift it by this. Okay, when we just keep X and X, they were overlapping. So if they were like this, they were overlapping like this. Now if I have to shift them, I shifted this left and I shifted this a bit right. Okay, that's what I did over here. And I said value is 1 and value 2, bar width is this for bar width over here. Then I said label is store 1 and store 2, and I had these labels over here, and they were, let's suppose, my stores. Now category of product category. Okay, this is the category of products A, B, and C. These are the sales I had, and these are the stores. And this is called as group bar chart, because now you made a group comparison. You might have seen this in cricket also, where they make a comparison of overs for both the teams. In this over, these many in the first power play, second power play, third power play, something like this, and they make a comparison of this. Okay, in this sort of style. And then we have 3D bar charts also, where we have multivariate analysis. You have two axes, X, Y, and Z. You have things. I'll just show you, and maybe we'll see it in detail once we go to 3D analysis. So here I have X, I have Y. Okay, this is the mesh grid that I'm plotting. Then I am plotting this random variable Z. Now I have 3 axes, X, Y, and Z. So if I'm plotting this, so you'll see a bar chart like this. Okay, these are bars, but they are in 3D now, and the function that is there is bar 3D. Okay, so this was about the bar chart. So in nutshell, you can see that in bar plot we can perform comparison of if we have categorical data. Categorical data is of different category. We saw website traffic can be there. We saw population by age. We saw different sales of our stores can be there. This can be the data, and maybe the house pricing also, something like that. If you have let's suppose houses in which we have these many number of bedrooms may range from, let's suppose, from 0 to 10. We can say for the 0th bedroom we got this price, and for if we have only one bedroom, we'll get a price range of this. So you can analyze the categorical data like this. Any questions on this? Any questions? Let's move ahead. Now the next plot that we'll see is called as stem plot. Okay, so what is the stem plot? So a stem plot, this is also known as stem and leaf plot. Okay, it's again a graphical representation of the quantitative data. If you have a data and you want to show it somewhere, and it somewhat looks like a bar graph, but it has some other things. It does not have rectangular things, but it has a line and a point, and these points like this. So this thing is called stem, and this is called, these are called as leaves. Okay, so this graph looks like this. It's called a stem plot or stem leaf plot. So it will have a stem and it will have these leaves. So now what is the stem? So the stem is a vertical line. So this vertical line represents let's say I'll show you the data, because it's pretty hard to understand like this if I directly plot these things. Let's suppose you have some data. So in this data, what I'll do, I'll actually take some data. So I have the data like this. So I have data which I have points. I have data like this, 12 and 15, 18. I'm just writing the data on this so that it becomes easy. 12, 15, 18, and 11, 13, then 16, then 22, 25, and 38, 34, something like this. Okay, I have this data. Let's suppose if I have to plot this data. Okay, this again is something. Agar mujhe ye data ko, if I have to make sense out of this data. Okay, now what I'll do is, let's suppose so I can just take these digits out. I can take this ones and out, and I can that's what the stem is called. I was speaking about the stem and the leaf. So what stem will do is, stem will take all of these numbers except the last number. So if you have the stem, so stem, what will stem do is, that the vertical line, it will basically, for example, if you see this, so it will take this number over here. So we have this 1, so it will take out this number. Even you can plot it in your way. So some people plot it like this. So we have stem and we have leaves. So stem, let's suppose we'll take this most significant number. So we'll take 1 and we'll take 2 and we'll take 3. And then we'll see this 1 over here is followed by 2. We can say 2. And then we have 5. We have 8. And we have 1 also. Okay, then we have 3. 1, 3. Okay, and then 6 also. Something like this. And for 2, what we have is, we have 2, we have 5. And for 3, we have 8 and we have 4. Okay, you can see this. Now the number starts with this. Okay, you have these numbers, and you can, this is the data that is, I have basically compressed this data into this data. This will be shown in on the stem, and this will be shown on the leaves. Okay, let stem will be like this. So stem, it will be on 1, then it will have 2, it will have 5, it will have 8, again this is 1 and 3, something like this, and this will be stem and the leaves. Okay, why is this very important? And you might be asking this question to yourself, what is this representation for? Let's suppose if you want to see the cumulative thing, you have let's suppose players. You have players like this. You have player names 0, 1, 2, 3. 0, 1 and 2 are the players, and correspondingly you have been given the number of goals they scored in different games, maybe 5 games. So there will be number of goals over here. So these things will serve as stem, and the number of goals with these they'll serve as leaves. Okay, and you can see the plot. Okay, so this player has scored these many goals. Okay, I'll just plot these things first. I'll show you the plot. And if you see the documentation, you will get confused, because I myself were confused for the first time I saw them. I was like, this plot doesn't make sense to me. Okay, now I'll plot something and you should be able to make sense out of it, at least given the background I gave you right now. So now what we have is, let's suppose this is my stem. 1, 2, 3 is my stem. It may be players, and these are the leaves, the goals that they scored. Okay, and then what I'll do is, I'm converting stem and leaves to numerical data. Okay, so I'm just adjusting it like this. For I in stem, enumerate the stems, and for leaf and I leaves, append this. So I'm making a list of X and making a list of Y, basically adjusting this for the readability. And then similar thing, figure axis. By now you should be experts. Now this is the syntax, axis dot stem, and rest of the things you know this. So if you see this is my stem. For one stem it has 12, this is 15, this is 8. Let's suppose this is 12, 15, 8, and it basically says, so if this is player 1 has scored in the first game 2 goals, then 5 goals, and then 8 goals, something like this. Okay, and if stem is 2, and then this is the number corresponding in here, you can see accordingly. Okay, 21, 23, 26, something like this. Okay, and you have to make it more readable. That's why usually you will see this these stem plots, but it is not heavily used. I have not used it much, but just as it was covered, so I just wanted to show you the stem plots. Okay, the more important plot now will go, which probably many of you will use, is called as area between two lines, area plots. Okay, just for the sake of completion, I covered this this plot, stem and leaf plot. So now we have area plot. Area plot you will use many other times. Okay, what is this area plot? So there is a function called as fill between. We have seen that. So in Matplotlib, it will fill the area between these two, highlighting the different regions. So I'll tell you why it happens. Let's suppose you are in the stock market or something like that, or maybe you're comparing something. So you have a graph like this. One graph is like this. You had one graph like this. Okay, this is, let's suppose, your expected thing. You are running a company, or maybe you are saying, I am running a company. It's listed in the stock, and I want this expectation of growth, or my stock value should be this. And in actuality, you got something like this, Okay. So what you can see is over here, this is above expectation, and you want to color it in a certain way. You say, okay, I want to color it this in this way. Okay, and this was below expectation. I want it to be red or something. So you want to color it, and this area will tell you how much off were you, how much off was your guess, something like that. If you have data like this, if you are comparing two quantities, and you want to fill in the values, and you can fill in with different colors. Okay, so as to get sense of the data. I just say the example. If you are having a company or playing a cricket match, this was the expectation, and something was expected. And you had the actual values, then you can just fill in the value and to see the error margin, basically how much is the error. So x-axis will represent an independent variable. It may be time, it may be categories. Then we have this y1 and y2. These are the dependent variables, represent two lines. There will be two lines. So we'll have this x and we'll have this y1 and y2. So this is y1 and this will be y2. We'll have two, and fill color we'll fill color in between them, or maybe above, below them. Okay, and the first thing is, as I said, finance. So which are revenue. So you had revenue and expenses. You have maybe revenue and you have expense. You want to see is there a loss or a profit. Okay, something like that. You want to do climate studies. You show temperature variations and their range, and it will help you in seeing the climate trends. You have sales data. You had this much of sales, and the market trend was this. You can see it there. Okay, I'll plot many of the graphs at once. Okay, how to plot these things? So I'll just create some data which I have randomly created over here. I'll show you that data, and then we'll get the sense of what this fill between is. This is the data. Okay, so I am keeping this months, that they are my months, and this is my revenue, these are my expenses, temperature, to high, low, sales A product, sales B, because these are the things I am comparing. Okay, I am comparing population, comparing sales A product, pills, temperatures, I am expenses, revenue, and disease A and disease B. I have taken different examples. I'll show all the examples at once. Now you know how to create how many plots will we create? 1, 2, 3, 4, 5 plots. Okay, now what we'll do is we'll say 3 cross 2. So we'll plot 3 cross 2. Let's create a figure. Okay, now I have created, oops, I should have created figure by now. Figure and axis, I'm saying 3 by 2, and this is the figure size. Okay, 15 by 15. And now I have to select each of these, and you know how to select each of these. Axis of 0, 0. Now if I have to plot a revenue versus expenses. Okay, I'm saying axis of 0, 0 fill between months, revenue, expenses, and I am giving a condition where revenue is greater than, give the color green. Wherever the revenue was more than the expenses, show me that this in color green. And if the revenue and expenses are less, then show me in the color red. Okay, and give the labels. This is profit area and this is loss area, as I was showing you. And then plot this. So if I just, let's suppose, plot it, you can see it. Let me just make something, a value should be greater. So this is our expenses. So we'll show you the loss. Somewhere we'll make the loss. So expenses 80. I'm always making greater. I'll make it 160. I'll make it 220. So I sometimes am in the loss. You can now see. So this region I am in loss. Okay, this is a loss region, and this all that region that maybe we'll make it a bigger. We'll say we have more losses. So this is 220. We'll make it 250. We'll say this is 250. We'll say it is 300 as expenses. Now you can see this again. The first thing is, you can see out from this. So when you were in these months, so in these months I had loss, so you can clearly say this is loss area. Okay, and how much area, you can see how much loss is there, and you can see that this is the profit area, and the green line is my revenue and the orange line is my expenses. That you can clearly see. This is the fill between months and revenue. Okay, and revenue and expense, I'm plotting them, and I'm giving a condition where revenue is greater than this. So in this condition, I'm saying where revenue is less than or equal to, and giving the colors accordingly. And alpha is basically for transparency, and I'm giving the label, and then I'm saying plot this. So this plot will plot the lines, this plot and this plot will plot a line, and this will fill between. Okay, and then I'm setting the title, setting the label, setting the legend, and saying grid is equal to true. So this is my profit loss revenue in the finance, if I am working in finance. Let's suppose you want to see the climate change. Okay, now I'll plot the second plot. This is my second thing, so second axis. So I have this axis 0, 0. Now I'll say axis 0, 1. If I select that, and I want to now see the climate change, so I'm saying fill between months and temperature high and low. Okay, and again the similar thing, plot this and fill between each of these. And here I am not giving between condition, I am just filling those variations. So if I now print this, you can see this thing should get printed on this. Okay, so this was the high temperature, and this was the low temperature. In between, this is the range of temperature change. Okay, how much change was there? I filled this area over there. Okay, and third case, let's suppose third case study could be a sales. So you have sales for product A and sales for product B. So if you want to plot, and I want to plot, this is 0, 0, and then we have 1, 0, 1, and then we have 1, 0. Again doing the same thing. So if I plot it for 1, 0, fill between months and sales for product A and sales for product B. And now what I'm saying is, so where sales of A is greater than this, put it in the purple and say product A sales area. So this is product A. So if sales area of product A is less, then print that this is B product sales area. Okay, because more of these got sold. And then if I, again the same thing is, you have the plot and you have this fill between. If I print it, this is how these graphs look like. Okay, now we have this product A series, because always we have given the value of product A to be more, so we can do it on purpose to make it less. This is the data that we had. Product A is this, so we'll make it 100, so we'll make it 20, something like this, maybe 150, something like that. We'll make it 180. Oops. So if I now print it, you can see this. So this is where the product A, this is product A, this is product B, and this is product A sales area. Product A sales because product A was selling more, and this is product B. So here you can clearly see. And one more example is plotting the population or the health. So I'll plot two more things at the same time. So now you saw that in this example, we saw how can we basically plot multiple things together also. So we saw we plotted multiple things. We plotted at least 5 plots. Okay, at least we had 6 plots, but I have given the 5 examples here. So now I'm plotting population studies and the health data versus disease incident, something like this, and the same area. So you can see all these things over here. Look, these graphs do look beautiful. So I'll just shrink them a bit so that they fit on the screen. So let's put it on 8 by 8 if it fits on screen. Yes, it did. And but again they are overlapping, so we can say that layout is tight. Okay, so we can see that figure, but anyways, you got the point. It's not required even, because if unnecessarily we got an error, we have to just debug the code. Okay, so let's suppose if I want to adjust the layout, I'll say plt.tight layout, and rectangle is between this. Now it should be better. Okay, so you see how beautiful these graphs look, and if you have a presentation to you can use these graphs directly. Okay, and this is the fill between, and I showed you certain conditions also. Okay, let's suppose with the sign and cos, we'll fill in the conditions also, again because these things were some practical examples. Sometimes you'll be doing a bit mathematics. So what in that one, let's suppose you have these two plots, you have plots for sine and you have plots for cos. So you have this data created on x, then you have y1 is sine, y2 is cos, and now you want to say fill between this where y1 is greater than y2 and this condition. You are given the conditions also and fill in the color accordingly. Okay, you can see the colors. Okay, based on these conditions, you can read the conditions. So y1 basically is the sine, where sine is greater than cos and x is less than 5. So the value of x-axis is less than 5. So again y1 is less than y2 and x is this, and give the color accordingly. So here you can see that I filled these colors. So you can see this is sine and cos. Okay, and you can fill in horizontally also if you want to fill horizontal. So we have seen the horizontal value also, fill between x. Okay, this was fill between y, so x also. So if you just want to see that, it will be something like this. You can fill in any way possible that you are having. Okay, is this fill between clear? I have shown you different examples, at least some case studies from the real world where you will use this fill between. At least we have seen this finance, revenue and expenses, climate studies, sales of product, population, and these health diseases and sort of things like that. And you will use a lot of these graphs in real world where you are comparing the things. I think we have a question. Yes, go ahead.